We have been looking at all the ideas about the equation of a straight line. So the ideas of midpoint, distance, gradient, finding the equations of the line, and drawing those lines up, inequalities with the line. The only thing we haven't done is another function, another formula. It's called perpendicular distance, which allows us to do a bit of extra work and solve some more problems with the equation of a straight line. So what is a perpendicular distance? Well, the idea is that if we've got a point and a line, the shortest distance to that point is the perpendicular line. So that's why we look to get the perpendicular distance, because from that point to the line, the shortest point is a perpendicular from that line to the point. So the formula we're going to use is related to the equation of the line. So we've got the line ax plus by plus c. That should just be ax plus by plus c, and the line and the points x1, y1. We take the equation, we take the point and substitute it into the line. So that would be a numerator. So we take the equation of the line, substitute the point into that line, and then in the denominator, it's the square root of a squared plus b squared, which is the coefficients of x and y. So that's where we start to use that formula. We do take the absolute value of it, because this on top may give us a negative answer. It just depends on where the point is. The points on this line, the point here to the line and the point here to the line, would be the same distance. It's just one's in one direction, one's in the other. So one would give us a negative and the other one would give us a positive. But remember, when we take a distance, we want the actual magnitude, not the direction of it. So we would only take the positive answer. So that's why we ignore the negative and put the absolute values there. So how is it applied? Well, we've got a point 2,5. We've got an equation of a line 3x minus 2y minus 1 is equal to 0. Make sure it's in that form. It's got to be ax plus by plus c form is equal to 0. So everything's got to be on the left hand side, because we want to put that form into our equation. So where we get the 3 times the 2, the 2 times the 5, and minus 1. And we'll do that calculation. We've got 3 squared plus minus 2 all squared. So that's going to give us positive answers there, because we're going to be squaring those ones. So that gives us root 13 on the bottom. 6 minus 10 minus 1 gives us a minus 5 up the top. We take the absolute value of it. And the absolute value, we need to say, if we're not too sure about what that is, that basically just takes those two lines describe the distance or the magnitude, not the direction. So if it's a positive answer, it stays positive. If it's a negative answer, those two lines make it a positive answer, and that's all the absolute value does for us. Makes it so we can take the positive of that. So sorry if you weren't too sure about that. Don't know if we've explained that in class to you before. Show that the point half minus 1 lies on that line. So that's pretty easy. We substitute half, we substitute 1 in, and we see that the left hand side equals the right hand side. So that's good. So that makes sure sure that we've got that point on the line, and then hence find the perpendicular distance between the parallel lines. So what it's saying here is you've got two lines and they're parallel. So if that's the case, then the closest distance, or the distance between them, will always be the same, and it's going to have that's where it's going to be perpendicular as well when we draw the line. So it doesn't matter where it is. A perpendicular line to both those will give us the shortest distance, and will give us the same distance every time. Distance between them stays the same. Now, if this point, a half minus 1, so say a half minus 1 lies on 6x minus 8y equals 11, then you could find the perpendicular distance from that point to the other line. So the point lies on that line there, so we can find the equation, use the equation of the other line, and use the perpendicular distance formula to actually find the distance between them. So notice we've got 6x minus 8y. We take the 31 across in our equation, so we manipulate it, because it's got to be equal to 0 here. And then we take the half minus 1, substitute it in. We've got our square root of a squared plus b squared on the bottom. That gives us square root of 100 on the bottom, which gives us 10, so that simplifies nicely. The numerator comes to minus 20, and as we said, we want to take the absolute value because we want the distance, not the direction. So we take the positive of it, so 20 divided by 10 gives us 2. So that's how that one works. So the idea there is a bit of a problem that we've got. The idea that between the two parallel lines, you're going to have the same distance everywhere. We just need a point on one of them. Hence, find the perpendicular distance from this point C to that line, and hence determine the equation of the circle centre C. We'll talk about that in a moment. Let's find the perpendicular distance. So we've got the point C to that line, so we've done our substitution, done our calculations, and it's come down nicely to 2 units. So even though it was minus, we took the absolute value, so we got the positive. So what does that mean for us when we've got there? Because it says hence determine. Now where we see the word hence in a question, it means use what we've just done. So again, if we weren't sure what that word means in a problem in mathematics, and you will see it a lot, we get the idea that we use what we've just done. So obviously we want to use this distance in the equation of the circle. Now what we've got, we want to find the equation of a circle that is at the centre's at minus 3, 1. So we go minus 3, 1 there. So our circle would have a centre there, and we want a situation where we've got a circle. We'll just draw a quick circle up, but hopefully it's not too ugly. And a line, and we have an equation, and this line we have here is a tangent. So I'm not sure if exactly where it is, but an idea that of a tangent there just touches the circle. Now where it just touches the circle as well, it actually meets the circle at the radius. If it's just touching the circle there, it would have the same distance as the radius, because the radius goes from the center of the circle to the outside of that circle. Now we just worked out from that the point minus 3, 1, the distance between that and that point and that line was 2 units, which means that the radius of our circle must be 2 units, because the point and the distance from the center to the circle is the radius, but also the distance from that point to that line is 2 units, and it's the same as the radius, because it's the tangent just touches, so it's exactly touching at that one point on the circumference of the circle. So that 2 allows us to get our radius of our circle. So the radius of the circle is 2. Now if we remember our circle equation in this form, we talked about this one before, x minus h all squared, y minus k, and r there, where the center of the circle would be hk. So if we've got that situation, our center of our circle is minus 3, 1, so that's where that x plus 3 comes from, because h would be minus 3, and y is equal to k is equal to 1, so that's where we get y minus 1. So remember, it's going to be x minus h and y minus k. And the radius we just determined was 2, so we square the radius there to give us 4. And that would be the equation of our circle. That tells us, when we look at this, we've got a circle with a center at minus 3, 1, because that's the values in there give us that, and the radius of 2. So that's how we started to use it to solve problems. We didn't really get told much about, but we did get a bit told. We knew we had to find a perpendicular distance, use a perpendicular distance. We had to make that connection that the distance there was the same as the radius, because the line was a tangent. So we've got a few more ideas to play with as we go through there. In the fourth problem here, a triangle here has these vertices, A2, 3, B, 5, 7, and 3, which is C, which is minus 3, 4. So find the length of AB. So we've got our length there. We find the distance formula. We've used that a lot of times. Remember, it's related to Pythagoras' theorem. And square root of 5 minus 2 all squared plus 7 minus 3 comes down to 5 units. That works out nicely. The next part wants us to find the equation of the line. So remember, to get an equation of the line AB, we need a gradient, and we've got a point. We've got 2, 3, and 5, 7, so that's not a problem. So we found our gradient. We used the point 2, 3, and 5, 7, and 2, 3, 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 5, 7, and 2, 3 to use this one. You could have used 5, 7. It will give you down to the same equation. But we put in our gradient. We put in our point. So multiply through 3y minus 9, 4x minus 8. Simplify to give us 4x minus 3y plus 1 equal to 0. Find the length of the perpendicular from C to AB. So if that's the case, we can use that formula, use that equation that we just had in part 2, substitute C into that equation, and we had the square root of the a squared plus b squared. So we substitute those values in, so we use the b, a and the b there. And simplify it, we get down to 23 on 5. Now we want to find the area of the triangle ABC. So what we've just done, we've got our triangle AB, we've got our ABC. So we just do a quick sketch. That's A, which is 2, 3. It's looking at not very much to scale, but that's okay. B is 5, 7, and C is minus 3, 4. So what we've just done there, to try and find that, in the part 1, you found the base here, which was 5. Then in part 2, you got the equation of that line. Part 3 asks you to find the length of the perpendicular to that line. And you found that to be 23 on 5. So now we want to find the area of that triangle. Now, the area of the triangle would be the half times the base times the perpendicular height. And you've got that from parts 1 and part 3, so we're able to substitute that into the equation for the area of a triangle. Half times the base times the perpendicular height. So that come from part 1, that come from part 3. So the questions led us up to this particular point. We needed all that information to find the area of that triangle. Do the simple calculation, gives us 11.5. So there's a typical type of question we see and get involved and have the perpendicular distance get involved, because it allows us to find the perpendicular height of a lot of these figures, whether it's a triangle or a quadrilateral. So it's not the last time you'll see that type of question. So be wary of that's what it's leading you up to. For when you're looking for the area in these types of problems, the previous parts will allow you to get that